front of each other at a certain distance, at a certain height, make sure that they're parallel to each other. Where would you start with that process? Where would you start to measure from? How would you ensure the accuracy of those two objects are sitting parallel to each other? And then what if I asked you to do that repeatedly over and over and over again throughout the day? That's essentially what we're trying to do with ADAS calibrations. We are taking a camera target or a radar fixture and we're placing those objects in front of the vehicle. All right. We're taking those objects for those camera targets, those radar fixtures, and we're placing them in front of the vehicle at a certain height, distance, making sure that they're parallel to the vehicle, making sure that the pitch is correct, the roll and the yaw are all correct. And the need for this is to be able to precisely place these objects in front of the vehicle so that the calibration can take place. So, the way we've done this in the past was, the OEM procedures required tape measures. In some cases, they were strings and plumb bobs. One of the Toyota procedures I saw one time was to tie a string to a stick, throw it under the vehicle to a waiting technician. Those two technicians then would take that string and align it on either side of the vehicle on the badges in the front and rear of the vehicle, and that's how you would find the center line, right? So, not exactly the most precise or the most intuitive process to do these measurements. So even some of the early OE tools required were made of PVC pipes. Like I said, strings, plumb bobs, really some really basic equipment. So these processes were very time consuming, and they were also very prone to error. So back in mid 2010s, Bosch came out with a system for vision positioning to do these calibrations. So we started with the SCT 415 and the SCT 17, which was a front-facing glass calibration product. The SCT 17 was a single camera solution that helped find the center line of the vehicle in order to set the calibrations up. Now we moved past that. In 2019, we launched the DAS 3000, which is here in front of us. The DAS 3000 utilizes a double vision positioning camera system. So we've got two cameras here on either side of the camera bar. We use that to measure the distance, the height, the distance, the roll, and the yaw of the camera targets relative to the vehicle. So in today's modern shop, this technology is essential for forward-facing cameras, for forward-facing radars. So that's kind of what I want to talk about today: is how this vision positioning has changed the game for ADAS calibration. So talking about tolerance and precision, right? The importance of both accuracy and precision cannot be overstated. Many of the original work instructions for the calibrations were kind of tedious. Like I said before, they depended on the human element to be able to make sure that they're calibrated, they're measured properly. But tape measures can be tricky, right? So I don't know how many of you are great using tape measures. I'm terrible at it. I'm notorious for measuring it a second time. It's off by a quarter inch here and there. So that's where the old adage of measure twice, count once came from. It's the same with ADAS calibrations, right? Having a technician go out there and manually measure this over and over again, and have them do that repeatedly throughout the day, that process gets tedious and tiresome. There's a lot of error that can be in the system when a technician is doing that manual process. So using something like vision positioning can help mitigate that human error factor. So that's kind of why Bosch started moving in that direction toward the vision positioning. A 2% calibration error potentially can impact the vehicle's path by up to 21 inches across 50 feet, right? A 6-degree calibration error can impact the vehicle's path by as much as 5 feet, or half a standard highway lane. And that's a distance that a vehicle covers in less than a second at highway speed. So these calibration errors are really critical. Now, if a vehicle is calibrated properly, if it's an accurate calibration, we won't necessarily need to worry about this. This is more for if a vehicle that has not been calibrated at all. We make us change the system. But what I really want to talk about is why. But kind of using a dartboard analogy, right? So accuracy is great, but it's really the precision that we're looking for, right? So if you throw a dart we land on the dartboard, that's great. We got it on the board. That's accuracy. But precision is really hitting that bullseye and hitting the spot where we need that vehicle to be at. I don't know how many of you have ever calibrated a Honda or a Acura vehicle. They require a two-step calibration process. There's first the static calibration, so using equipment like this, you set it up in the shop. The calibration is performed from a static standpoint, and then the vehicle needs to be taken out for a dynamic calibration. Those dynamic calibrations typically will take significantly longer if the static calibration is not as precise. A precise calibration, the dynamic will take a couple minutes. If it's imprecise, it could take somewhere in the range of 20 minutes to 30 minutes to complete the dynamic calibration, because the vehicle has to find that margin of error. So really, with that in mind, the precision is really critical when it comes to these ADAS calibrations. So the second benefit of the vision positioning is also the repeatability of the calibration. So we talked about before about the mitigation of human error. The vision positioning helps allow the human error to be kind of taken out of that calibration element. So when we launched the DAS 3000, that's here I've got here, we performed a numerous amount of time studies to understand the impact of vision positioning on the technician. As we expected, experienced technicians, ones that have done ADAS calibrations before, they were able to do these calibrations fairly quickly, somewhere in the range of 5 to 7 minutes typically. But what we saw is the inexperienced technicians that started out, they could do the calibrations in roughly 10 to 15 minutes, which is a huge improvement upon the OE standard time, which was roughly an hour and 15 in some cases. But what we noticed is that as those inexperienced technicians continued to do calibrations, they did more and more of them, they got faster. They were able to learn the system a lot faster without sacrificing any precision. So they were able to perform those calibrations at a faster rate and with less error as they learn how to do it. So for myself, I've done this calibration. We've got a Toyota Corolla over here. I've done it the last 3 years here at AAPEX. I can do this calibration now in about 5 minutes. So it's one of those things that as the technicians work on these and do these calibrations, they learn to do them faster. They're able to do them at a more rapid pace without sacrificing that quality. And then also, by adding this the vision positioning in there, adding the guided workflows, it creates a standardized approach for these technicians to perform ADAS calibrations. That's not only to help, like I said, improve their proficiency, but also helps them become more efficient and faster in that process. So the original, like I said, the original vision positioning system from Bosch was the SCT-17. That added on to the SCT-415 product that we had. But as we've launched the DAS 3000, we've added a lot of different targets. There's a bunch of new different targets that we've added in the past 2 years that add on to the script that utilize the vision position as well. Things like the Volkswagen and Mercedes rear camera system. We've got our Volkswagen and Volkswagen Porsche LiDAR board that utilize the vision positioning. Toyota 3-in-1 board, which we have here on the front, and then our new radar reflector stand, which I've got here. We're able to perform forward-facing calibrations of front radar systems that require the conical radar. So we're utilizing all these different systems with vision positioning. So really, like I said, the landscape of ADAS has been rapidly evolving. We're seeing a lot more new technologies coming out, the challenges of static calibration are not going away. They're going to continue to be here. Human error will still be a part of the process, but Bosch is really working to evolve and develop technology that will take the human element out of ADAS calibrations. So these tools really help to not only enhance the accuracy and repeatability, but they also help empower the technician as well. So it gives them the confidence to be able to perform these calibrations with repeatability and also with precision. So Bosch remains dedicated to continuous innovation, ensuring that our solutions will evolve alongside this ever-changing market. So we invite you to join us on this journey and embrace these advancements and elevate your calibration practices so that we can enhance safety and reliability of the vehicles that are on today's roads. Thank you so much.